Um, this unit has a lot of review in it. That's why I leave it for the end, because if we do run out of time, a lot of it you should have experienced and looked at some point. So here are the three main sections at the bottom here. First, we're going to deal with all kinds of triangles. Okay, that's where it's at. Like sometimes they're obtuse, right? Any shape of triangle. Then we're going to look at quadrilaterals. So what are quadrilaterals? Are four-sided polygons. So, right, your rectangle, your parallelogram, your trapezoids. These are all four-sided. Okay, and then we're going to talk about many sides. Okay, polygons, many gons, angles, many angles. That's what it stands for. So, hey, if you're as good as me in art, you will be able to do a pentagon no problem. And this is how I do my hexagon. I do the bottom part like this, and then I copy that. Hey, there we go. So that's what we're going to end up with, right? So triangles, quadrilaterals, and then polygons in general. But all of these can be put under the umbrella of polygons. Okay. Polygons is kind of like the overall, like it's a big umbrella that has all the shapes under it. So here we go. Ready? Page 2. Review some previous skills. Page 2. Symmetry. Isosceles and equilateral can be split in half because they're symmetric. Okay? So this is what I mean, like you can split it. So if you see this big triangle, you can split it. And so what happens to the 80 down here? Hello? 40, yes. 40 centimeters. The 50 stays. This 50 just comes over here. This is H. And when you cut it, we're assuming that there's a 90-degree angle here. Okay, so that's very important. You cannot, okay, folks, I'm going to use pink here. Do you see that this side, right, the 50 measures the same as this? That is the only reason you're able to split this in half. If these two sides are not the same, do not split the base in half because it's not going to be true. It's not symmetric, right? The center is off. So if you go down to the base, it's not going to be 50-50. All right. Over here, again, I look at these two sides. This is actually an equilateral, right? This 100 is, they're all 100, but I'm looking at these two, which means I can't split it in half. So this just divided by 2. So this is 50 centimeters. This is 100. And this is your 90, and this is H, right? So the 100 comes over, but we split the base in half. So check, check, check. But then the last one, I'm just going to make the point here. Should I? Yeah. So asymmetric. By that I mean this one is different than this one. Okay, asymmetric. You cannot divide by 2. This is wrong. Okay, I'm actually going to, this is wrong. Okay, you can't do that. Can split. Okay. So why am I saying this? Because a lot of students try this when they think they're stuck, right? They try that. It's like, don't do it. It's gonna be wrong. Okay. So that's the first concept I needed to review. Let's keep going. Each of the following, fill in the triangle to the right with as much information as possible. Okay. So what can we transfer over? Oh, sorry. I think I'm just gonna peek once. I think I forgot something. No, I'm good. Okay, good. Each of the following. Yeah, this 90 up here is very important. Highlight that. Okay, that is important. It's 90 degrees. Right? They give you an angle basically. So when we split, okay, when we split this, yeah, that's H. This angle gets split in half. So this is only 45 degrees. But also, let's not forget, do we know that these two sides are the same? How do we know that? They have that little marking. Okay, good. So this side is the same as that side. Okay? Therefore, it's symmetric. There you go ahead and split in half as much as you want, right? So the 45, what do we know about this angle here? It is a 90 because it's implied that H stands for height. Okay, so that's 90, and therefore 180 minus 90 minus 45, right? Minus these two is 45 degrees as well. So you plug that in. So if you pay attention, you can find out a lot of information just by going and applying the sum of triangles equal to 180 property, right? So I know that probably none of this is new to you, but I need to make sure you understand that before we move on. Next, again, I'm going to say this. You should see these markings everywhere. Okay? So you have marking and you have measurement. So that means that all of these sides are 7 centimeters. Okay? Yeah. I'll come and see you. What kind of triangle is this one? It's a name for it. Equilateral. Yeah, equilateral. So if all sides are the same, then you just go 180 degrees and split it into 3 equal angles. 60. So we know that this is 60, this is 60, this is 60. So you know a lot about this one. So if we split it, let me use a different color. If we split that, that's what we're going to call H. Okay, this comes over here. This 60, you can split in half to give you 30. We know that this is 90. And can we say that this is 60 here? Yes, in fact, right? This corner here gets copied over. But even if you weren't sure, you could have gone 180 minus 90 minus 30 and be left with 60. So regardless of how you do it, you should see that things kind of confirm and affirm each other. Okay, so there we go. Oh, there's one more thing that we could have added, or actually two things. 7 centimeters comes over, and the 7 here gets split in half to 3.5 centimeters. Okay, we can split that in half because it's symmetric. Sorry, I should have added all of that too. Here's some formulas that I would strongly suggest you add to your study sheet because they're not provided on the formula sheets. And I'm going to do something else here. The height of a shape is always perpendicular to the ground. Say what? What? Perpendicular means meets at a 90. Okay. So how do you know that's the height? Is if you have a 90 with the base, then you know you're talking about a height. Okay, this is your height. This is your height. And the reason I'm saying it is sometimes students think that this is the height, like that slanted piece there, and that's not the height. it meets at a 90 with the ground. Okay? So area of triangle, area of parallelogram, that's a parallelogram. Area of trapezoid, this is what we call a trapezoid, so you have to be familiar with those shapes. Keep going. I'm going to give you a crash course on Pythagorean theorem. And I know your teachers have used ABCs in the past, most likely. A squared, B squared, blah, blah. I don't do that because what if A is something else, right? Got a different side. So I use this. This is actually what Pythagoras figured out. That if you took the hypotenuse of a triangle and square it, and then you grab the other legs that make it, right? That meet at a 90, and you square both of them and add it up, you get the same answer. Okay, that was his hypothesis, right? It only works with right triangles, and you need 2 out of 3 sides for this to work. So it comes down to this formula breaks down into 2 cases. If the hypotenuse is unknown, you do this. You take the hypotenuse, or sorry, to find the hypotenuse, you simply take the square root of leg squared plus leg squared. If one of the legs is unknown, it doesn't matter which one, to find the leg, you take the square root of hypotenuse squared minus leg squared. There you go. That's your Pythagorean theorem. Basically, it's this one up here, but we manipulate it to look like either this or that. Okay. So if your parents ask you, what did you do in school today? You learned how to manipulate. Well, I'm gonna need to call your teacher. Formulas. You say formulas like after, right? At the end. All right. Keep going. Here are 2 examples you can try with. Calculate the length of the missing side. Here you go. You see that there's a 90. This is leg, this is leg. Okay, you've got both legs. The hypotenuse, which is the one across the 90, that's the best way to find it. Find the 90, across from it is the hypotenuse. That's unknown to us. Should write this down just to stay awake, right? To figure out the hypotenuse, I'm going to square root 7.6 squared plus 9.4 squared. So I'm going to show that intermediate step, right? Get your calculator. 7.6 squared plus 9.4 squared. 146.12. And then last but not least, you take the root of that. Yeah, thank you. There you go, hypotenuse. And it should be the longest side, correct? If it's not the longest side, go back, you made a mistake. So I think of it this way, if it's supposed to be the longest side, add. Leg will be shorter than the hypotenuse, you have to subtract, right? So here it is again. Across from the 90, hypotenuse. This is a leg, this is another leg. You don't know what that is. Let's use the variable in this case. X is going to be hypotenuse squared minus the other leg squared. You grab your calculator. And you go 17.8 squared. Don't forget to square. 158.08. Take the root, and there it is, 12.57. We are in inches. And it makes sense because it's shorter, it's shorter than the hypotenuse, so we're in business. Okay, next, page 5. I want you to try that. Just a quick, I'm not going to take too long. If you need additional help with that, I can gladly help you. But page 5, try those. Try to solve for the unknown using. I'll help you out with the last one. And this, it's just review, so every once in a while that comes in handy. So when you have two triangles like this, start with this one. Okay, because you've got most information here. So I've got the hypotenuse, the leg, and this is another leg. Let's call that x. So if you solve for x, if that's one of the legs that you're trying to find, you just have to root the hypotenuse squared minus the other leg squared. And that gives you 57, hold on, 3331.69. And that gives you 57.72 centimeters. So then for now, you found this. Okay. Based on this triangle here now, this is the hypotenuse. This is a leg, and so is this one. Like if you look at it from this side, this is one of the legs as well. So to find P, which is the hypotenuse, you just take this leg, 5772, square it, add the other leg, 46.9. Okay. If you do that, you get 5531.3. Rooting that gives you 7437 centimeters. This is the ultimate answer. Okay. So that's how you do one like that. It combines everything we've done. We're good? Don't look so happy, guys. Gotta smile every once in a while. Life is gonna be okay. Sometimes it's not the best. It's a little bit like you just have to drag yourself through it. Once you graduate, it's gonna be a happy day. Working with triangles. This is true for all of them. Have three sides. They're closed, meaning all sides connect. And the sum of interior angles is always 180. Please don't forget about this one. It's so powerful. It can get you out of a situation where you seem stuck.
Hi, Mr. Justin. Sorry to interrupt.
Yes.
Is Roel in class this afternoon?
He's not.
Okay, thank you very much.
Yeah. Classifying triangles. Okay, this is the meat and potatoes of today's lesson. Classifying triangles. We're basically, if you ask to classify triangles, we're gonna go first name, last name of the triangle. This is my own thing, okay? Like it's not in a textbook or anything. So you basically will have to, say you're gonna have to pick one of these three in terms of the first name of the triangle, and one of these three for the last name. Okay, every single triangle fits into one of these three categories and these three categories. Okay, first name, last name. I don't really care if you mix it up, but I will call this first name, and this I'll call last name. Okay, write that down. It's just gonna help you to know that you need two names for the triangle. Okay. So a triangle is either going to be acute, right, or obtuse. Okay, this is the most important one. For you to have a right triangle, you need one angle that measures 90 degrees, just one, and it turns into a right triangle. That's You might think, yeah, duh, I know that already. But just remember, all you need is 190 and you're done. You already know the first name. Acute, I will highlight this part. How do you know a triangle is acute? All three angles are less than 90. All three are less than 90. So you have to check every single one. Obtuse, I'm going to use a different color. I'm going to use green. Obtuse, one angle is greater than 90. One angle. One. Question, can a triangle have more than one obtuse angle? Can it have two 91s, for example? 91 and 91 is what? 182? It's already more than 180. Sometimes they ask questions like that. Okay. So can't have more than one obtuse angle, only one. Side length, I'm going to use colors as well. Equilateral, three sides and three angles are equal measure. That's how you know it's an equilateral. Isosceles. Isosceles is when two sides and two angles are of equal measure. Scalene. Have you heard of a scalene triangle before? It's probably the most popular one, but you haven't been given a name for it. So scalene, what does it say? All sides are different and no angles are equal. So basically, all three angles are different, all three sides are different. Okay. Let me see here. I want to give you a little bit of a heads up here, but I don't know if I'll tell you this on the side here, okay? You ready for this? Tip. Knowing all three angles always allows us to classify we don't need the side lengths. You're the first group that I ever tell this to. Just because I'm going to try it. I'm going to try it. Don't need the side lengths. All you need is all three angles. Okay? If you're able to somehow know all three angles, you can classify that thing. You don't need to know side lengths. But it doesn't work the other way. If you have all three side lengths, you cannot classify just like that. We have to go further and actually calculate. I'm gonna give this another, I'm gonna like go all out on this one. I think we need a bit more. There you go. That ought to do it. Okay, so all three angles always allows us to classify. We don't need to side lengths to keep going further. Okay. For example, if you have a triangle where all three angles are different, you know it's scalene. And because you're going to be able to see the angles, you'll immediately see which one of these three it fits into. Okay, so keep that in mind. Why can't a triangle have more than one obtuse angle? Explain. Okay, like let's say you have angle A, angle B, and angle C. If this is 91 and this is 91, because they're both obtuse, this is already 182 degrees, which is greater than 180. This cannot be true all triangles have a sum of 180 degrees. Okay. So basically, that's one of the ways you could have explained that. So there's not even a way to give C a measure. C doesn't even have, it's already past 180, so it cannot be. I feel like I should, for all of my lessons, I should come up with like a short rap song where I like dance and sing to it. I bet you then you'll remember. You can't unsee that, right? Anyways, I'm not gonna do it. You'd have to pay me too much for that. Anyways, let's keep going now. Now we're gonna put this into practice. So today is all about classifying triangles. That's all we're doing today. But there's gonna be different ways that I'm gonna ask you to come up with that. Okay, some are gonna be this fast, like you honestly just gonna look at it and boom, first name, last name. Some of them you're gonna have to do some calculating. So come with me. Page 7. Page 7. This is just to help you out. Okay? Steps to classify a triangle. Look for side lengths or angles given. It could be markings or actual values. That's the first thing I would say observe. Okay? Number 2, can you calculate any missing sides or angles? Use Pythagorean theorem. That's what PT stands for. Okay? Pythagorean theorem. Can you use sum of triangles 180? Can you use sine or cosine law? Okay? All of this we've learned before. Right? All of this we've learned before. There's nothing new here. You know Pythagorean theorem. You know the sum of triangle. You know sine law, cosine law. Sine law, cosine law, only worst case scenario. Okay? We're not going to go there right away. Conclusion. If all angles or sides are different, it's either an acute or an obtuse scalene. Okay, so I'm going to highlight that part. All are different. We know for sure it's going to be something scalene. If two angles and sides are the same, you know for sure it's going to be something isosceles. It's going to be either acute or obtuse. Okay. And the last one, are all angles the same? This one is the easiest one. Definitely an equilateral. It's always acute since all angles are 60 degrees. So that one you know for sure. Can I say all angles or sides? Okay, then you know you have an equilateral scenario there. So for your study sheet, okay, listen carefully to this part. Small, not too big, because you got to be conservative with your space. I would strongly suggest you have at least classified by angle, acute, right, obtuse, and then right next to it, classify by side length and have equilateral isosceles scalene, so you remember the names in case you need to be reminded of the names. Okay. So here we go. Let's do this one more time here. I'm going to do my cheat sheet right here. By side, I have equilateral. I have isosceles, and I have scalene. That's by side. Okay. By angle, if I want to also classified by angle. I have acute, I have right, and I have obtuse. So we're going to use this to help us out. That's how you can probably make it smaller, because some of you writing, I wish I would have had that neat of writing that you have. I'm just not able to do that. Okay. So let's observe here. This first one. All sides are different. That's the first observation. We're looking at the sides, the markings. We know that all are different. How do you know they're different, Mr. Dirksen? 1, 2, 3. That means all sides are different. Okay. I look at the markings. Ouch. And what about angles? What comes to mind here? 1 right angle. You see that? There's 1 right angle right here. So let's name this now. Out of these 3, which one are we going to pick out of these 3 here? Scalene, because all sides are different. So just go ahead, scalene. Scalene. And the second name, this would be right. Mr. Dirksen, but I don't know the other 2. I don't know this one. I don't know these 2. It doesn't matter. Yeah, first of all, the markings tell us that all 3 angles will also be different. If the sides are all different, all 3 angles are different. But we just care about the 90 because everything else isn't going to change. The fact that the 90 is here automatically tells you that you have to call it right. Scalene right, or this is the most proper way of doing it, is saying right scalene. It doesn't matter. No deductions will be given for not having them in the right order. Let me just try one more thing here. I try, right? So by side, that's where we pick this name, right? The orange. By side, that's the scalene part. And by angle, we chose right because we knew that there was 1 right triangle. Okay. Okay, let's do another one. This one. What do we notice? Equilateral, how do you know? All 3 angles marked equal. If one of them had 2 little markings, that's then different than the rest, okay? So 1, 1, 1. So therefore, it's equilateral. But Ms. Erickson, we don't know the side lengths. How can you call it equilateral? Because this is 60, they're all the same. So you split 180 into 3, so it's 60. We are guaranteed that all 3 sides will be the same also. That is just a conclusion you can make. That's a relationship between the angles and the sides. If all 3 angles are the same, all 3 sides are the same. So all 3 angles marked equal. Therefore, all sides are equal as well. This is our conclusion that we've made. Mr. Erickson, can I go acute equilateral? Because you always say first and last name. Yes, you can, because all of them are less than 90, correct? So this is technically acute. So if you'd like to, the province says that they don't, if you say equilateral, you'll be fine. But technically, by side length, it's equilateral. By angle, it's technically acute. And I can go further. All angles less than 90 degrees. That's why we came up with that name. Fun stuff, eh? I know. I know. I warned you it's going to be a lot of fun. This one. Can you know one of the names right off the bat? It's a right. Okay. That's so if you have two blanks, you should probably say, yeah, this is definitely right because of that. Done. That's it. Okay. What about the rest? Watch carefully. Because of these two sides being the same, you're with me, right? You're looking up, right? We are guaranteed that the angles across from these two are going to be exactly the same as well. Okay, that's just an observation I make. But really, we just need, if two sides are the same, we know this is an isosceles, correct? And I'll say this, two sides. Remember this symbol? Did I show you this symbol before? This is congruent, the same. And isosceles, obviously you already know why. So the right part I told you because it's a right triangle. So we went right in terms of angle, and isosceles because two sides measure the same. Don't leave these blank, just try it. Worst thing, you have no chance if you don't put anything down, right? But if you do put something down, at least you have a chance. Okay, this one. What could you do here with this one if you had to do this? Ronan, did you have an answer? Did you have your hand up or no? What would you do with this one? You've got two angles, correct? Find the third one. Find a third angle. That's what I would do. Because right now there's too little info, okay? Not enough info. So just by observation, there's not enough info. So let's find this one, okay? So question mark is going to be 180 minus 30 minus 20. Question mark is 130 degrees. So you put that in here, 130 degrees. Are all three angles different? Please follow me on this one. Remember when I said if you have all three angles, you can classify? All three angles are different. So therefore, come with me. This is a lot of fun actually. All three sides are going to be different. We don't know what they are, but I can guarantee you all three sides will be different. So here we go. First and last name. In terms of angles, what are we going to call this? Obtuse, because there's one obtuse angle here. 130 degrees. I'll just put that in brackets right under. And second name, scalene, because we're told that scalene is when all three sides are different. Scalene. Three sides different. We don't know what they are, but we know that they're different. That's just how it goes. When the angles are all different, all three sides are different. If the angles are all the same, all three sides are the same as well. Two angles are the same, two sides will be the same. Okay. I'll do one more and then I want you to try this, okay? Come with me. Please don't overthink it either, because sometimes students overthink it and then they get it wrong because there's way too much effort in it. Okay. So what would you do in this scenario here? Observe, observe. Make a note of this. If those two sides are the same, so are, look at this. If this is the same as that, you can make this conclusion. Watch. Yes, this is 25 also. It must be, or else something is wrong with trig. Okay, whoever invented trig did it wrong, right? So if this is the same, so are the angles across from them. Got it? This was locked in. This was locked in there, and then I just made that conclusion. Hey, you guys, right? You are both the same. If it's 25 here, then you must be 25 also. Let's call this A here. This is my angle A. I don't know what it is right now, but I can easily find out. Angle A is 180 minus 25 minus 25. Why is it 130 again? I should change my numbers a little bit. But anyways, don't make a conclusion that it's always 130. That's all I'm saying. Now you know that this is 130. And remember, if you have all three angles, you're in business. You're done. You can name this thing. First name, last name. Based on the one obtuse angle, this is obtuse. Right? You just determined that, and you cannot have more than one obtuse angle. That's already done. We're done. What about this part right here? Based on the side lengths. Two are the same. Okay, isosceles. Two sides are what we call congruent. I'm going to use this notation later on again. Think of it as equal, but it really means congruent, meaning they're the same. Mr. Erickson, could it be though that this side is still the same as the other two? Is it possible? No, because this is 130. If this had been 25, then maybe, but right, but not. So you can actually go and make a two lines to distinguish it from the other two. Okay. All right, I'm going to stop for a bit. And I want you to try these three here that remain, okay? And sometimes all you have is the diagram. You don't put in a number that doesn't belong there, right? You can quite often come with numbers, but this one down here in G, you just look at it. Like you have to make your decision based on what it looks like, okay? So try these three and then we'll continue. Okay? First and last name. I will hand out your tests, okay? That's right. So this is 180 here. These two sides are the same, and so you should be thinking, okay, right, crisscross them like that. That means that these two angles are the same as well. So you can go 180 minus 80, which is 100 degrees. The 100 will be split equally amongst those two, so that's 50 degrees. So this is 50, this is 50. There we go. So we know that this is based on the angles. This is what? Acute. And based on the side lengths, it's 50. Hey, if the markings hadn't been there and the 50s had been there, we would have come up with the same conclusion, right? That this is an isosceles. Okay. Next, you see a right here. I would actually start like saying, hey, it's right something. Next, I find this angle here. I go 180 minus 90, this one, minus 45. I end up with 45 again. So you plug that in. So we know that, right? This side right here will be the same as that side over here based on the angles. We don't know what they are, the measurements, but we know that they are the same. So isosceles it is. Okay, bingo. Then this one, no numbers, nothing. This we're guaranteed is an obtuse, correct? Just by looking at it. Remember I told you, no, never mind. I was gonna say make a connection with trig, but I'm just gonna leave it for now. But obtuse, so this is obtuse for sure. And it's scalene, why? Because all three sides are marked with. So there we go. For homework, you ready for this? If you pages 9 and 10, as well as 11. So pages 9 to 11. Hold it, hold it. While I'm handing out the tests, okay, let's go to 11. I need you to also go the other way. If I give you the name, can you graph it? Can you sketch it? An acute scalene. Okay. Acute means all angles are less than 90, correct? So just make sure you don't have an obvious obtuse. Just sketch one of those. And then the acute part, we can go 40, 80. What does that add up to already? It's 120, correct? So how much is left? 60, right? 60. So now you're saying all angles are different and acute, and then you can go with the markings like this just to make sure you've actually are making sure both categories are met. Mr. Dirksen, did I need markings on this one? Not really, because all three angles were different. But I would still say it's probably a good idea. If there's an obtuse, folks, that's the one I need to see clearly like this. Like make the obtuse and then close it. It's an obtuse isosceles. So let's make this 100 degrees, let's say. That is guaranteed an obtuse. How will you make sure it's an isosceles? How? Marking, marking, right? Those two are the same. So it's an obtuse isosceles. So you got to be able to do that as well. Okay. So I'm going to ask you to do everything up to 11. I will post the key